Direct air capture is one of the many climate engineering technologies that are being developed to remove carbon dioxide from our atmosphere and offset the global warming effects that greenhouse gases are causing to our planet. Direct air capture, or DAC, is the process by which ambient air is pulled into processing facilities by big fans, and the CO2 is removed from the air using one of multiple different proprietary processes. From there, the CO2 can take one of two paths. It can either be buried safely underground, or it can be used to make products such as synthetic fuels or building materials. The company that is leading the efforts to scale DAC is 1PointFive. 1PointFive is in the final stages of construction of a DAC facility in Texas named Stratos that they project will be able to remove 125 times the amount of CO2 as the biggest DAC plant currently in operation in the world. They plan to open Stratos later in 2025 with the lofty goal of capturing 500,000 metric tons of atmospheric CO2 per year. They're also planning a second DAC project in Texas with plans to capture 1 million tons of CO2 per year to start, with long-term plans to capture up to 30 million tons a year. The environmental impact of the planned 1PointFive facilities is yet to be determined, but one of the main points of controversy around DAC is that currently 75% of all the CO2 that is pulled out of the atmosphere in this way is being used for enhanced oil recovery, or EOR, and 1PointFive and the construction companies they're using to build Stratos are all owned by Occidental Petroleum. While advocates for using the captured CO2 for EOR say it's technically a greener alternative to conventional oil extraction, and the CO2 is then captured underground in the process, critics say that enhanced oil recovery processes aren't monitored closely enough for that to be confirmed as a net negative. The technology of DAC is solid, and there are more than 24 facilities currently in operation worldwide. Most of these facilities are still pilot programs, which are not operating at a scale that is impactful to atmospheric CO2 removal. But investments and subsidies are being made by the US, Canada, and the EU, as well as private companies, to bring this technology to a more meaningful scale. Currently, the economics are challenging as the cost to capture for most of these companies in operation is somewhere around $1,000 per metric ton. For the process to make sense financially, government subsidies, operating cost reduction strategies, and economies of scale must be achieved for the cost for capture to land between $100 to $200 per metric ton, because that's the price carbon removal buyers want to pay for carbon credits. While the technology of DAC has been widely politically accepted and governments around the world are actively investing in it, critics say that because the process is so energy intensive, that even if clean energy is used in the process, that energy would be much better off going back into the grid to offset the use of power that is generated by burning fossil fuels, and that is the main source of our global warming problem, and should be the main focus of climate engineering technology policy and investments. From a risk and uncertainty management perspective, DAC presents a low risk and is generally considered very safe. As currently 75% of the CO2 captured by DAC goes into enhanced oil recovery, and that oil companies are the ones leading the way in scaling this technology and benefiting from the government subsidies, the priority needs to be auditing the EOR process with a full life cycle analysis in order to determine whether it's truly net carbon negative, as today this is something we are unable to determine with data. My biggest takeaway from this research I performed on DAC is that while the technology has very little potentially harmful impact to the environment, except for its high energy usage, this technology is at best a supplement to what our overall atmospheric CO2 reduction strategy should be. It's exciting to see this technology working in the world today, but with the overall scale that needs to be achieved for us to combat global warming, the focus needs to be on other climate engineering technologies, or soft geoengineering solutions, like reforestation and afforestation. as trees are the best natural solution to absorbing CO2 in the environment and offer the cheapest and most scalable solutions available to us, while also providing a whole host of other environmental benefits. Thank you.